So dear students, last class we have discussed about the atomic mass, molecular formula, and the mass percentage of elements contained in the compound. Okay, so now we will discuss about the empirical formula and their relationship with the molecular formula. So empirical formula is the simplest whole number ratio of various atoms which is present in a compound. So similarly, the water molecule, for example, water molecule, the molecular formula is what? H2O. Okay, so there are the two types of atoms, hydrogen and oxygen, and the ratio between hydrogen and oxygen is 2:1. That means two numbers of atom in hydrogen and one numbers of oxygen. Okay, so 2:1 is the ratio, and this is also the simplest ratio. Okay, but the molecular formula represents the exact number of different types of atoms present in a molecule of a compound. So in case of H2O, 2:1 is the molecular formula ratio as well as the empirical formula ratio, because 2:1 is the simplest ratio. But for example, for the compound ethene, C2H4, this is the structure of ethene. The structure of ethene, C2H4. The ratio of carbon hydrogen 2:4. This one 2:4, and the simplest ratio is what? 1:2 divided by 2, 1, and 4 divided by 2, 2. So simplest ratio is 1:2. 1:2. So this is the empirical formula ratio. This is the molecular formula ratio, and this is the empirical formula ratio. Okay, so empirical formula of ethene is this one, CH2. Okay, similarly for the compound this one, C2H4 Cl2, this one dichloroethane, and ratio is 2:4:2, comparing carbon, hydrogen, and fluorine. And this is number of hydrogen, 4 is the number of hydrogen, 2 is the number of carbon, and 2 is the number of fluorine. So simplest ratio, this ratio is to be divided by 2. So this one 1:2:1. So this is the empirical formula ratio, that means the simplest ratio, and this is the empirical formula, that is 1:1. That means number of carbon atom is 1, number of hydrogen atom is 2, and number of chlorine atom is also 1. Okay, next on, this is a structure of the C2H4Cl2. This is a molecular formula structure. So now a question is, a compound containing 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Its molar mass is given, that is 98.96 gram. What are its empirical and molecular formulas? Okay, we have to calculate the empirical and molecular formula. So now step 1, the percentage composition of the elements containing the compound is given by this one, 4.07%, 22.47%, and 71.65%, and this percentage composition is to be converted into gram. That means amount of element, that means amount of hydrogen, iman gram, this is 4.07 gram, and amount of carbon 24.27 gram, and amount of chlorine 71.65 gram in 100 gram of the compound. Okay, so next step, it should be converted into number of mole. So number of mole means what? Weight divided by atomic mass. Okay, so amount of hydrogen is 4 gram, approximate 4 gram, and amount of amount of at atomic mass of hydrogen, this one 1 gram, 4 by 1, this is approximate 4 mole. Okay, and number of mole of carbon, this is 24.27 gram divided by 12 gram, because 12 gram is comes from the, this is the atomic mass of carbon, 12. Okay, so 24 by 12 approximate 2 mole. So similarly, number of chlorine, 71.67 gram, 71.65 gram divided by 35.5 gram. This is 35.5 is the atomic mass of Cl. So this is 2 mole. So this one divide, this ratio is what? The ratio of number of mole of hydrogen, carbon and chlorine is 4:2:2. Similarly, the simplest ratio, the smallest ratio is 2:1:1 for hydrogen, carbon and chlorine. So empirical formula is this one, CH2Cl. So number of hydrogen is 2, this one number of carbon is 1, and number of chlorine is 1. So this is the empirical formula, but we have to calculate the molecular formula also. So next one, we have to calculate the empirical formula mass. Okay, this one empirical formula mass, CH2Cl. So C, 12 gram for carbon atom, 2 into 1, this is for hydrogen, and this is Cl. Okay, this it is found to 49.5 gram. So dividing molar mass by empirical formula, this is the empirical formula mass 49.5 gram, and this is the molar mass. This was given in the question. So this molecular formula divided by molecular formula mass divided by empirical formula mass is equal to approximate 2. Okay, so we have to multiply the empirical formula divided by 2. Okay, where n equal to 2, so molecular formula is equal to empirical formula into 2. So where empirical formula is what? 2CH2Cl and n equal to 2, so C2 is 4Cl2. So this is the required molecular formula. Okay, so this is the process to calculation empirical formula as well as the molecular formula from percentage composition of a compound of elements. Okay, so next topic is limiting reagent. Limiting reagent, this is the when a chemical reaction is undergoing to form a product. Suppose A is the reactant and B is also a reactant and C is the product. When we add 5 gram of A and 5 gram of B to produce 10 gram of C, after some time, suppose after 10 seconds, T is equal to 10 seconds, after 10 seconds this 5 gram will decreased to 0 gram, and 5 gram, this 5 gram of B decreased to 2 gram. That means this 5 gram decreases, becomes 0 gram, and this 3 gram decreases to form 2 gram of B. But in this case, after 10 seconds, amount of A will be 0 gram. That means there is no any amount of reactant A present in the reaction vessel. Okay, so this A, reactant A, is called the limiting reagent of the reaction. Okay, so a reactant which is present in the least amount get consumed after some time, and after that further reaction does not take place. When the amount of A becomes 0 gram, thereafter the reaction does not take place. Okay, whatever be the amount of other reactant, hence the reactant which get consumed first limits the amounts of product formed and is therefore called the limiting reagent. So this reagent A gets consumed fast and 0 gram, there is no amount of A in the vessel. So this reagent A is called the limiting reagent of the reaction. Okay. So next class we will discuss about the concentration terms, mole fraction, molarity, normality, molality, etc. Okay, thank you.